right, so this is a complex example. It's the chain rule twice and the product rule. And then simplifying that, which that's usually the part that students really struggle with, is the simplification. All right, so this is going to require both the chain rule twice and the product rule. That's what makes this one hard. There are technically 4 functions. There's the 2 inside functions, the 2 outside functions, and then the groups are multiplying by each other. So this would be my first function. This would be my second. When I take the derivative of the first, it requires the chain rule, and when I take the derivative of the second, it requires the chain rule. All right, so the derivative. Use the product rule and then the chain rule while I'm doing the product rule. All right, so the chain rule is, or the product rule is, then the chain rule. Product rule is, it's the first, so write down the first without doing anything, so 1 minus x to the fourth, times the derivative of the second, which is where I'm going to require my chain rule. The derivative of the second is the chain rule. I take care of the power outside, so I pull that 3 down. Rewrite my group raised to 1 degree less. 1 degree less would leave that a 2. I'm not done yet. That's just the outside. Then I have to remember times the derivative of the inside. The derivative of the inside of the second function would be a times 2. Right, because the derivative of 2x is 2. The 3 zeros are out. All right, so there's the first. This is the first times the derivative of the second, which required my chain rule. Then there's a big plus to separate them. The second times the derivative of the first, and that requires my chain again. Alright, so the second, 2x plus 3 cubed, times the derivative of the first, which again is going to require my chain rule. The first thing I do is pull that power 4 down. Take my group 1 minus x raised to 1 degree less, which would be a cube. Not done yet. And this is one would be easy to forget. The derivative of the inside, well, the 1 will zero out, but the derivative of x is 1. But remember, there's that negative in front of the x. So the derivative of the first function's inside part is a negative 1. And that one, if I were going to forget something, that's the one I would forget. All right, so there's my rule. Step 1, the rule. Now the simplification. And when I simplify, you can always factor out the group you used the chain rule on. Because there should always be one of them, at least one, that shows up in each part. Alright, so you've got 2 terms separated by plus. You've got this first term separated by a plus and this second term. Alright, that's it. Those 2 terms. I'm going to factor out my common groups. And so the common groups I can factor out, well, I've got 4 1 minus x's here, and I've got 3 there. And you can only pull out the smaller amount, which means I can pull 3 of those out. And then I've got the group 2x plus 3. I've got 2 of them here. And I've got 3 of them there. And I can pull the smaller amount out, which means I can pull 2 out. So that's what we're going to simplify. We're going to factor out the common groups, as many of them as I can. Alright, so I can factor out the group 1 minus x, but I can only pull 3 of those out, because I only have 3 of them in the second term, which means I'm going to have 1 left over in the first term. When we factor, it's a multiplication, right? Factor undoes the multiplying of expressions. So it's times, the next group I'm going to pull out is 2x plus 3, and I can only pull 2 of those out because I only have 2 in the first term, which means I'm going to have 1 left over. And there should always be 1 left over. Because of how the chain rule works, I always subtracted 1 when I took the chain rule. So I should always have 1 of those groups left over in a term. Alright, there's the, and so then what I do, again, this is just a personal quirk, times what's left over. And I put brackets around what's left over because usually we have to simplify what we have left once I pulled those groups out. So in the first term, I pulled out 3 of those, which means I had 1 of those left over. Got 1 of them. I pulled out both of those, so that group is gone, but I still have a constant 3 and a constant 2, which I multiply those, that means I've got 6 left over as well. So I've got one group, x, 1 minus x left over, times the constant 6, because I had 6 left over. Alright, that's all that's left over in the first. Then we separate it by a plus, because there's that plus that doesn't disappear, it's still here. What's left over in the second term? Well, the second term was left over is I pulled out all 3 of those, so those are gone. I only pulled out 2 of those, so I still have 1 left over, and you'll see there's one group of each left in each term. Alright, that's just that one. And then I have a constant left over. I had the 4 and the negative 1, so I had a negative 4 left over. Alright, and so there's what's... and I put brackets because that reminds me what's left over needs to be simplified. Usually that involves a distributive step and a collect-like term step. Alright, so here I'm going to distribute my 6. Here I'm going to distribute my negative 4. Alright, so out front, those groups don't disappear. They still come along. They're still an important part of my function, so they come along. Inside my bracket, I'm still simplifying, so I've got a 6 minus a 6x when I distribute. I've got a negative 8x minus a 12 when I distribute there. And then my last step is to collect my like terms in that bracket. So these come along again. And then when I get to my last step, you can leave it brackets. It doesn't matter. It's a grouping symbol. But I put parentheses back when I know I'm done simplifying. And I know I'm done simplifying once I collect my like terms. So negative 6x, negative 8, going to give me a negative 14x. 6 minus 12 is going to give me a negative 6. And there is my function completely simplified in factored form. So it's simplified into factors. I've got 3 factors here, and that's important. It actually, when we go to do stuff in the next sections and applications, we want it in this form. So that's why we need to practice simplifying those, all right? And so there's an example of the chain rule, the product rule, and simplifying. And so I'm going to stop the video there because this is one that students typically have trouble with, and so you might have to come back and reference this video again. And so I'm just going to do this one example, and we'll pick up the next example in the next video.